Hi, my name is Mr. Kangas, and today we're going to be taking a look at Chapter 5, Section 7, Adding and Subtracting Unlike Fractions. In this video, we're going to talk about adding and subtracting unlike fractions without monomials and variables. And in the next video, we'll be talking about how to add and subtract unlike fractions that have monomials or variables in them. Essentially, this process combines, let's go with 9, combines chapters 5, 6, and 5, 5, where we will be using LCM to find a common denominator, at which point we will be using chapter 5, 5. And we'll be adding fractions that have like denominators. So the first thing you need to do is you need to find the LCM of your two denominators, because you cannot add these fractions unless they have like denominators. The way I explained it in the previous video on adding fractions was essentially the denominator does not tell you how much you have. That's what the numerator tells you. I have 3 out of 4 pieces. Not only does the denominator not tell you that, but what it does tell you is how big your pieces are and how many pieces it takes to make one whole. So the reason why I say it tells you how big your pieces are, why it tells you how big your pieces are, is because if I have a pizza and it's split into 4 pieces, I know that my pieces of pizza are bigger than a pizza that's split into 9 pieces. That's essentially what this denominator is telling you if you think of it in terms of pizza. I have a pizza split into 9 pieces, and I have a pizza split into 4 pieces. One of them obviously has much bigger pieces. So if I just added these up and said that I had 8 pieces of pizza, because up here it says I have 3 and over here I have 5, I can't really say I have 8 pieces of pizza because 5 of my slices are 1/9 of a slice, and 3 of them are 1/4 of a slice. So these ones are much bigger slices than these ones. So if you're going to tell someone how many slices of pizza you have, you typically want to be referring to a standard or defined size. You don't want to tell someone, oh hey, I'll give you 20 pieces of pizza, but then give them pieces of pizza that are only, an inch wide. They'll probably be pretty upset with you. So when you're adding, you need to add things that are the same size, essentially is what it comes down to. And to do that, you need to make the denominators the same size. So we need to find the LCM of 4 and 9. So we have 4 and we have 9. So in order to find LCM, just a quick refresher, we need to do the prime factorization. 4 is really easy, it's 2 times 2. 9, really easy as well, it's 3 times 3. So prime factorization of 4 is 2 times 2. Prime factorization of 9 is 3 times 3. At this point, I would look for any factors that they share. So if I had a 2 here and a 2 down here, I would then circle them and cross off the bottom one. In this case, they actually share 0 factors. The 9 is made up of all 3s and the 4 is made up of all 2s. So we have nothing to cross out. So we're just going to multiply all these numbers together, and we actually get an answer of 36. 2 times 2 is 4, 4 times 3 is 12, and 12 times 3 is 36. So our common denominator, or LCD, the least common denominator, is going to be 36. So I'm going to make my new problem that has common denominators. To go from 4 to 36, I have to do 4 times 9. So 4 times 9 is 36. So if I'm going to multiply the denominator of 4, so let's take a look at it like this. Okay, if I'm going to multiply that denominator of 4 times 9, I also have to multiply the top by 9. So 3 times 9 is 27. Now the reason why I have to multiply both top and bottom by the same number, if I have 3/4 and I'm multiplying it, the top and the bottom by 9, what I'm actually doing here is I'm creating an equivalent fraction. My fraction's 3/4 is not worth any more or any less than 27/36. I've actually created the same number, it just looks different. 27 divided by 36 gets you the same answer as 3 divided by 4. Remember, this fraction bar means divide. Now, when I multiply both top and bottom by the same number, what that does is it actually multiplies my fraction by 1. Because if you recall, when you multiply fractions, you just simply go straight across. So if I'm multiplying both top and bottom by the same number, it's kind of like I'm multiplying 3/4 by, in this case, since I'm multiplying both top and bottom by 9, I'm multiplying 3/4 by 9/9. And what is 9/9 equivalent to? 1. 9 divided by 9 is 1. So I've actually multiplied 3/4 times 1, in essence, to get 27/36. So 27/36 is actually equal to 3/4. So now, I'm going to take a look at 5/9. To get from 9 to 36, I did 9 times 4. So to get my new numerator, I have to also do 5 times 4. I have to multiply top and bottom by the same number. At this point, we have two fractions that have common denominators. So now I can add 27 plus 20 is 47. Denominator stays the same. I have 47 over 36. If you want to, you can turn it into a mixed number because this is an improper fraction. That would be 1 and 11/36. So just to recap real quick, I found the LCD, or the lowest common denominator, of these two fractions by actually finding the LCM of the two denominators. To find the LCM, I found the prime factorization of the two numbers, crossed out, and circled what they had in common, the pairs of numbers they had in common, cross out the bottom one, then multiply what's left over, and I ended up with 36. Another way to find a common denominator when you're doing this is just to multiply the two denominators together. That can work, but sometimes that will get you really big denominators for your new problem, which you don't want to deal with if you're being required to reduce. Lowest common denominator will limit how big your numbers are and how much you have to reduce. So after I found the lowest common denominator, I had to find my new numerators. So I figured out that I had to do 4 times 9 to get to 36. So since I multiplied my denominator by 9 to get to the new one, I have to multiply my old numerator by 9 to get to the new one. And since I multiplied this old denominator by 4 to get to 36, I multiplied this old numerator here by 4 to get to 20. And we discussed briefly how when I multiply both top and bottom by the same number, I'm actually multiplying the fraction by 1, because by multiplying it by the same number, I have the same number on top and bottom here. 4/4 is the same as 1. So when I multiply 5/9 times 1, I should get an answer that's equivalent to 5/9. And you actually get 20 over 36, which if you reduce it, is 5/9. 5/9 and 20/36 are equivalent. They have the same value. And I know that because I just multiplied 5/9 by 1. So once I got my common denominators, my new numerators, I just added the fractions because now they have common denominators. So you can just add the numerators. 27 plus 20 is 47. You always keep the denominator the same because the denominator does not represent what you have. It represents what makes one whole. So that number hasn't changed. What has changed is how many pieces I have or parts I have. That's what the numerator represents. By adding these together, I've gone from having 27 pieces to 47 pieces. We'll do one more example real quick. We'll do 4/3 plus, let's go with 2/16. So, or actually we'll do 12, and we'll do 30, we'll do 32. So we're going to find the prime factorization of 12 and 32. So that means we have to do the factor tree, because we want to find the lowest common denominator of these two numbers. So to do that, you have to find the LCM. So this is all part of the process of finding the LCM. So the prime factorization of 12 is 3 times 2 times 2. Prime factorization of 32, we're going to do the factor tree again. I know 8 times 4, 2 times 4, 2 times 2, 2 times 2. And the reason why I'm kind of going through this rather quickly is because I do have videos on finding LCM that take it a little bit slower. If you don't remember how to do this, then by all means, please watch the video. So the prime factorization of 32, or you can just pause this video. Prime factorization of 32 is 2 times 2 times 2 times 2 times 2. So at this point, when I'm finding prime factorization, when I'm finding LCM, my bad, you circle what they have in common, which in this case I have 2 pairs of 2. I'm going to cross out the bottom and then multiply what's left over. So I've got 2 times 3 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48, 48 times 2 is 96. So what that means is my LCM, or in other words my LCD, is 96. So my lowest common denominator is 96. And remember, lowest common denominator is the same thing as the lowest common multiple, or LCM, of those two numbers. So now that I have my new denominators, I need to find my new numerators. If you don't know how many times 12 goes into 96, or what times 12 is 96, you can use a calculator to figure that out. Just do 96 divided by 12. I happen to know it. I know that 8 times 12 is 96. So since I did 12 times 8 to get there, I've also got to multiply the top by the same. So I'm going to do 4 times 8 and get 32 for my new numerator. To get my new denominator, I multiply 12 times 8. So to get my new numerator, I'm also doing 4 times 8. So, how many times does 32 go into 96? It goes into it 3 times. I know 32 times 3 is 96. So I'm also going to do 2 times 3 and get 6 as my new numerator. Okay. At this point, you take the numerators, add them together, keep the denominator the same. You can reduce. You don't have to. Some teachers may require it, so you're definitely going to want to know how to do it, but that is an acceptable answer. Okay. And just real quick, actually I'll save that for another video. That really in a nutshell is how you add fractions with unlike denominators. If you were to subtract fractions with unlike denominators, The process is exactly the same. The only difference is when you get down to, let's go. When you get down to that point where you have your common denominator, you want to make sure that you're using KFC. Once you get down to that point where you have a common denominator and you're ready to subtract, use KFC. Keep the fraction on the left the same, flip subtraction to addition, change the sign of the number on the right to the opposite. That way, you know whether or not your answer is going to be negative or positive. If you take a look at this, the number next to the negative is bigger than the positive number, so I know my answer is going to be negative. And because I have different signs, I'm going to subtract the two numbers. 32 minus 6 is going to get me 26. Leave the denominator the same. And that would be your answer if you were to subtract those two numbers. Because remember, with subtraction, order matters. Okay, whether or not the 696 comes first or second is going to change the answer that you get. So you really want to make sure that you're using keep, flip, change to make sure that you don't mix things up. Okay, so the next video will be on adding and subtracting unlike fractions that have monomials in them. So tune in for that. Because that's all that we have. Oh, also real quick, if you're subtracting or adding fractions that have mixed numbers, so let's say we had 2 3/4 plus 3 6/10, you want to change these mixed numbers into improper fractions first. 4 times 2 is 8, plus 3 is 11. 10 times 3 is 30, plus 6 is 36. And at this point now we would find the lowest common denominator, and then we would add them together. So always turn the mixed numbers into improper fractions. Other than that, the process is exactly the same. You treat these like you would any other two fractions. So tune in for the next video.